In the next couple of videos, we will take a look at JUnit and see how this can be used to write tests for our Java program. So JUnit is an open source framework or a set of classes for writing tests for Java classes and for automating the execution of these tests for Java classes. There's two main flavors that are still in use, JUnit 3. These test classes used inheritance, so you set up test classes that inherited from test case or test suite. But we will use the later version of JUnit, which is JUnit 4. This uses Java annotations and therefore it needs Java 5. Even though you could use JUnit 3 with Java 5, these days most people use JUnit 4, and that's what we will use. So there's some documentation that's available at JUnit.org. We just pull that up. This is what it looks like. So you can download and install a guide. Download and install JUnit. And there's some information about how to get started in JUnit. There's also the API documentation, which is unfortunately at a different site. Let me pull that up. Oops, I guess I don't have it. But it's easy to find. Let me just take a second. JUnit, you can just search for JUnit API. And there it is. So there's a whole bunch of classes. The main one that we'll be using is assert. Okay, so that's what this framework looks like. There's a whole bunch of classes that you use, and the main way that we will use it will be through Eclipse. But before we get there, I just want to say a few things about JUnit. There's a JUnit wizard in Eclipse, and that's probably the preferred way to set up classes. You could set up classes from scratch, but this is definitely easier. So if you start up the wizard in Eclipse, it can set up a new test class. Depending on the version, if you use JUnit 3, your test class will extend JUnit.framework.testCase. In JUnit 4, it no longer uses this. And we will stick with JUnit 4. So typically each work class, or suppose you have a program with a bunch of classes, and those are the classes that you want to ship with your product. Well, each one of those classes should be tested by a separate test class. And the test class will have these kinds of methods, not exactly these. So there will be a setup before class. This sets up for a suite of tests, and then there will be a setup class which will set up objects for a single test, and then you do a test of some method in the work class. So this will be in the test class. All of these methods will be in the test class, and then there's a teardown, that's cleanup after a test, and then teardown after class. So clean up a whole bunch of things after testing a class. Okay, so it is possible to set up a test class for, let's say, each method of a class under test, but that's probably that's probably overkill. To minimize the proliferation of such test classes, test methods exercising the same class are grouped in the same test class. So one test class will usually test all the methods of a single work class. And so these test methods will share a single setup before class and a teardown after class. So typically when you run a test, and we'll go over how to do that, the order in which things will get executed is you set up everything you need for a suite of tests. So you call the setup before class, and then you create instances of the class under test, and you call a setup, you test, you tear down, you call setup, test, and tear down. And there can be more than just two. We're just, in this case, we're assuming that there's just a test x for the x method and test y for the y method in the class. So x and y are methods, let's say, in the class that we're interested in testing. So we'll set up, test the method, a method, tear down, set up again, test the method, tear down, so on, and then finally tear down after the class. So this kind of thing is useful when there's many tests that require common objects. You share the setup before class and the tear down after class. Okay, so, and also typically there is at least one test method for each method of the work class. So let's say we have a method called last index of string. So if you're testing that method, chances are we'll have a method in the test class that tests that method in the work class. So this is our method in our class that we want to ship, but we want to test it before we ship it. So each method like this will have a test method, and this is the kind of thing that gets done is you do various things, and you finally call, when you're all set up, you call assert true and then some condition. In this case, this condition has to evaluate to true. So each test in a method each test that we want to execute will be in a separate method that usually starts with the word test. It doesn't have to, but this is how things were done in in JUnit 3, and JUnit 4 just kept it, even though it no longer needed to. We still have that structure. Okay, so the assert class is what's used to signal if we got a test right or if the test failed. And there's a whole bunch of methods in the assert class. So where is this? This is in, you can find documentation in here. Here's class assert. This is in the Java Doc API for JUnit. So here's a whole bunch of methods. Might be hard to see, but this is assert array equals. There's a whole bunch of them. And then assert equals is something that's commonly used. And there's a number of them, so there's more than I indicated, but the common ones we'll go over. We won't have a chance to really go over every single one of these assert class methods. Okay, so these are the common ones that I think we are more likely to run across. There's also fail method, which basically says test failed, and so you can imagine that you can use some logic. If some condition is true, then you can do something like assert true with a true inside it, which will is guaranteed to pass, or just don't do anything. And if that condition is not satisfied, you can call the fail method, and that way we know that our test failed. Okay, so Eclipse 4.3, which is what we're currently using in this demo that's coming up next, comes with JUnit versions 3 and 4. The current version of JUnit 4 is 4.11. And JUnit has 3 test runners: text-based user interface, swing user interface, and AWT user interface. I believe we're going to be using the swing user interface. We're going to use the graphics one. Okay, so when testing a method that is expected to throw an exception, we have to do some special handling. What we should do is use a try-catch block and use the fail method to catch instances where the exceptions are not thrown. So for example, if you want to make sure that exceptions are thrown, use a try-catch block and then put a fail right after the statement that should throw an exception. So if it throws an exception, we can do something like catch an assertion error, for example, and print out a message. Okay, so now let me break here and go to Eclipse and take a look at the simple class that I've set up to test. So let's say the class that we're going to test is called Simple Computation. It's got a couple of data members, got a constructor for initializing those data members, and then some compute methods. Very simple. It's just data member 1 minus data member 2. So there you go. Data members A and B, they're floats, and one of them just computes the difference, A minus B. Another one computes the division, A divided by B. Okay. So you might say, well, that's kind of easy. Well, it's supposed to be easy so our test will be easy to start out with. So the first thing we have to do is we have to make, and what I'm going to do is make a new source folder and call it unit tests. Okay. And in here, what I'm going to do is I'm going to say new, and if you see this, something like this, JUnit test case, that means your Eclipse is perfect for doing JUnit. If you don't see it, you might want to look in here. So you should see in here, scroll down to Java, and you should be able to see JUnit and JUnit test case. So we briefly talked about test case and test suite. A suite is a whole bunch of test cases run together. We no longer need to use that. We can use, if you use JUnit 4, we don't need test suites. We can just use test case essentially. Alright, so I'm going to click on comments. I'm going to say, oh, I should give it package. It's always a good idea. Tests. And then call this simple computations test. And then the class we're testing is simple computations. Alright, that should be good. Go next, and here we get a chance to select the methods that we want to test. I'm just going to choose all of them and click on finish, and at this point it'll say JUnit 4 is not on the build path. Do you want to add it? Yes, you do. And so we add JUnit 4 library to the build path. You do need that, and we're all set. So let's just take a quick look before we can run this. Take a quick look at what this set up. It set up a class, simple computations test. Doesn't really extend anything because we're using JUnit 4. And then what you'll see is here is a before class, after class, and then a before, after, and then test. If you're looking at just the annotations, you'll see a whole bunch of tests. Notice that they all fail. So we can try this out by saying you can run it. There is no main. That's the thing that surprises people. There is no main here. You just say run as, and it should say JUnit test. I hope you can see this. Maybe you can't. Unfortunately, I don't know how to make that appear here. So hope you can see this now. Run as JUnit test, and it ran a whole bunch of things, and it basically says they all failed. Why is that? Because we asked them to fail. In the beginning, when you set up tests, you just set them up to fail, and then later on we write the actual tests themselves. Right now they don't really do anything. Okay,